Let us now apply these concepts in some engineering principles. Let us try to understand how to convert between the two different temperature units, the units of Fahrenheit and the units of Celsius. The equation that relates these two quantities is the following. Fahrenheit units, or temperature in Fahrenheit, is equal to 9 over 5 times the temperature in Celsius plus 32. So in this example, we observe that the slope is 9 over 5, or 1.8, and the constant is 32. So we could have written this equation in the form of the dependent and independent parameters. Y equals mx plus b. So in this one, we observe the constant to being 32 and the slope being 9 over 5, since degrees Celsius will be the independent parameter. Let us now find out the temperature that we will have if the temperature in Fahrenheit. Let's say that our temperature is 20 degrees Celsius. What is the corresponding temperature in Fahrenheit? In order to solve this, we need to substitute this temperature of the independent parameter in the equation for degrees Fahrenheit. So F will be equal to 9 over 5 times 20 plus 32. And this result gives us a temperature of 68 degrees Fahrenheit. What if the temperature in Celsius had been 40 degrees? The corresponding temperature in Fahrenheit will be 9 over 5 times 40 plus 32. So what we find here is that the corresponding temperature is 72 plus 32 is 104 degrees Fahrenheit. Of course, we can take this information now and develop a plot. On the independent axis, we will place degrees Celsius, and on the dependent axis, we place degrees Fahrenheit. So when the temperature is 20 degrees Celsius, we have a temperature of 68 degrees Fahrenheit. When the temperature is 40 degrees Celsius, we have a temperature of 104 degrees Fahrenheit. And then we also observe that when the temperature is 0 degrees Celsius, we are at 32 degrees Fahrenheit. This is our y-intercept. And then we are going to draw a straight line that goes between those points. And this straight line shows to us that as the temperature in Celsius increases, there is an increase in the temperature in Fahrenheit. Now, how can we manipulate this equation and assume that we know the degrees Fahrenheit and we would like to find the decrease Celsius. So now we are changing the independent variable to becoming decrease Fahrenheit. So our original equation is given as F equals 9 over 5 C plus 32. So we need to rearrange or manipulate this equation in the form of decrease Celsius equals to a slope times decrease Fahrenheit plus the constant. So let's do so. I'm going to subtract from both sides of this equation 32. And if I do so, I find out that F minus 32 is equal to 9 over 5 times C. The next step will be to try to make the right-hand side the dependent parameter. And we can do so if we multiply this by 5 over 9. Now, when we multiply that by 5 over 9, in order not to change the equality, we have to multiply the left-hand side by 5 over 9. So this simplification now, or this step, yields the following equation. It says that C, which is the dependent parameter, is equal to 5 over 9 F minus 5 times 32 divided by 9. And of course, once you have this equation, you can assume values of F and find the corresponding values of C. Or you can also plot it. So as an exercise, find the corresponding temperature in degrees Celsius if the decrease Fahrenheit is equal to 32, then if the decrease Fahrenheit is 68, and if the decrease Fahrenheit is 104. What are the corresponding degrees Celsius? Of course, once you perform the algebra, you should end up with the same values that we had in the previous slide.